Welcome to Keen's on Science. This is part of my SLOP series, looking at shed loads of practice for GCSE chemistry revision, and these questions are about titration calculations. Let's dive straight in. Question 1 says, calculate the concentration of hydrochloric acid in moles per decimeter cubed. We're then given some information on the titration, where we're told that we've got 25 centimeters of hydrochloric acid reacting with 23.5 centimeters of 1 mole barium hydroxide. So we've got to calculate the concentration of hydrochloric acid. We've got two equations. We've got the number of moles equals concentration times volume, and concentration equals number of moles divided by volume. First thing we've got to do is calculate how many moles of barium hydroxide. We're told the volume of 23.5 and we're told the concentration is 1 molar. The volume needs to be in decimeters cubed, so we need to divide it by 1,000. So 23.5 divided by 1,000 times by 1 tells the number of moles of barium hydroxide. We then need to use that to calculate how many moles of hydrochloric acid. If we look at the equation, we've got twice the number of moles of hydrochloric acid compared to barium hydroxide. So we multiply the number of moles by 2 to tell us the number of moles of hydrochloric acid, which is 0.047. We can then use that to calculate the volume of hydrochloric acid. Again, we're told the volume of hydrochloric acid is 25, but we need it in decimeter cubed, so we need to divide by 1,000, so that's 0.025. We can then calculate the concentration by rearranging the equation, and it's number of moles divided by volume. So we know our moles is 0.0047, divide that by our volume in decimeters cubed is 0.025. So our concentration of HCl is 0.188 moles per decimeter cubed. Question 2, titration calculation. We've got to calculate the concentration of sulfuric acid in moles per decimeters cubed. So again, we're given information from the titration. We're told the volume of sulfuric acid, and we're told that that's reacted with 25 centimeters of 0.1 moles decimeter cubed sodium hydroxide. We've got to use two equations, and it's number of moles equals concentration times volume, or concentration equals number of moles divided by volume. First thing we've got to do is calculate how many moles of sodium hydroxide. So we're told that we've got 25 centimeters cubed, but we need it in decimeters cubed, so we've got to divide by 1,000. So it's 25 divided by 1,000 times by the concentration, which is 0.1, gives us number of moles of sodium hydroxide, 0.025. We can then calculate how many moles of sulfuric acid. Looking at the equation, we've got 2 moles of sodium hydroxide to every 1 mole of sulfuric acid, so we need half the number of moles of sulfuric acid. So we divide the moles of sodium hydroxide by 2 to give us 0.00125 moles. We then calculate the volume of sulfuric acid, because we need it in decimeters cubed. So we know we've got 30 centimeters of sulfuric acid, so that's 0.03 decimeter cubed. So we divide it by 1,000. And then we can use that information to calculate the concentration of H2SO4. We know the number of moles and we know the volume. So it's number of moles 0.00125 divided by volume 0.03, which gives us a concentration of 0.0417 moles per decimeter cubed. Question 3 says calculate the concentration of sodium hydroxide in moles per decimeter cubed. So this is a titration calculation. We're given information about the titration. We're told the volume of sodium hydroxide that's reacting 25 centimeters cubed, and it's neutralized by oxalic acid. And we know we've got 15 centimeters of oxalic acid at a concentration of 0.048. We've got two equations to use to do the calculations, and the first thing we're going to do is calculate how many moles of oxalic acid. So we're going to use volume times concentration. We know we've got a volume of 15 centimeters cubed, but we need that in decimeters cubed, and we've got a concentration of 0.048. So we divide 15 by 1,000 to turn the volume into decimeters cubed, multiplied by 0.048, which is the concentration, and that tells us the number of moles of oxalic acid. We then calculate how many moles of sodium hydroxide. Looking at the equation, we can see there's 2 moles of sodium hydroxide for every 1 mole of oxalic acid. So we multiply the number of moles by 2. So we know we've got 0.00072 moles of oxalic acid multiplied by 2 tells us the moles of sodium hydroxide. We now need to calculate the volume of sodium hydroxide in decimeters cubed. So we know we've got 25 centimeters cubed. So we divide that by 1,000. We've now got the number of moles of oxalic acid and the volume. So we can use the second equation to calculate the concentration of sodium hydroxide. So that's 0.00144 divided by 0.025, number of moles divided by volume, which gives us 0.0576 moles per decimeter cubed of oxalic acid. Question 4 says calculate the concentration of sodium hydroxide in moles per decimeters cubed. Again, this is a titration calculation. We're given information about the titration. We're told the volume and concentration of citric acid, and that neutralizes 25 centimeters cubed of sodium hydroxide. We're going to use the two equations throughout this question. First thing we're going to do is calculate how many moles of the citric acid. So we're told we've got 13.3 centimeters cubed, but we need that in decimeters, so we need to divide that by 1,000, multiplied by the concentration, which is 0.05. That tells us the number of moles of citric acid to neutralize the sodium hydroxide. We can use that then to calculate how many moles of sodium hydroxide. Looking at the equation, we've got 3 times the amount of sodium hydroxide as we've got the citric acid. So we multiply the number of moles of citric acid, 0.00067 by 3 to tell us the number of moles of sodium hydroxide. We can then calculate the volume of sodium hydroxide in decimeters cubed. So we know we've got 25 centimeters cubed. So we divide that by 1,000 to turn that into decimeters cubed. We've now got the number of moles and the volume. Therefore, we can use the second equation to work out the concentration. So the concentration of sodium hydroxide is number of moles, which is 0.001995, divided by the volume, which is 0.025, to give us a concentration of 0.0798 moles per decimeters cubed. Question 5 says, calculate the concentration of potassium hydroxide in moles per decimeter cubed. It's a titration calculation. We're given information about the titration, including the volume and concentration of sulfuric acid, and that it neutralizes a certain volume, 25 centimeters cubed of potassium hydroxide. We've got to use the two equations throughout the calculation. And the first thing we've got to do is calculate how many moles of sulfuric acid. So from the information, we've got 15 centimeters cubed of 0.5 molar per decimeter cubed. So we need this in decimeters cubed. So we divide 15 by 1,000, turn it into decimeters cubed, and multiply it by the concentration. That gives us 0.0075 moles of sulfuric acid. We can use that to calculate how many moles of potassium hydroxide. We know from the equation we've got 2 moles potassium hydroxide for every 1 mole of sulfuric acid, so we need twice as many moles. So we've got 0.0225 moles of potassium hydroxide. We can then calculate the volume of potassium hydroxide in decimeters cubed. So we're told from the question we've got 25 centimeters cubed. So you divide that by 1,000 and we've got 0.025 decimeters cubed. We can then use the equation, concentration is number of moles divided by volume, to calculate the concentration of potassium hydroxide. We know the moles, we know the volume. So we've got 0.0225 moles, we divide that by 0.025 decimeters cubed volume. That gives us a concentration of 0.9 moles per decimeter cubed. Question 6 says find the concentration of sodium hydroxide in moles per decimeters cubed. It's a titration calculation. We're given information about the titration. We're told the volume of sodium hydroxide and we're told the volume and concentration of the sulfuric acid. We're going to use the two equations throughout the calculation, and the first thing we're going to do is calculate how many moles of sulfuric acid. So from the information, we're told we've got 18.8 centimeters cubed of 0.5 moles per decimeter cubed sulfuric acid. So first of all, we need it in decimeters cubed, so we need to divide 18.8 by 1,000 and then multiply it by 0.5 to work out our moles. Once we've got our moles of sulfuric acid, we can use that to calculate the moles of sodium hydroxide. We can see from the equation, for every 1 mole of sulfuric acid, we've got 2 moles of sodium hydroxide. So we simply multiply our moles by 2 So we've got 0.0188 moles of sodium hydroxide. We then need the volume of sodium hydroxide in decimeters cubed. So we've got 25 centimeters cubed, so we divide that by 1,000 to get 0.025 decimeters cubed. We've now got the number of moles and the volume. We can use the second equation, therefore, to calculate the concentration of sodium hydroxide. So that's 0.0188 divided by 0.025, which gives us a concentration of 0.752 moles per decimeter cubed. Question 7 says calculate the concentration of arsenic acid in moles per decimeter cubed. It's a titration calculation, so we're told the information about the titration. We've got the volume of arsenic acid, and we've got the volume and concentration of sodium hydroxide. We're going to use the two equations throughout the calculation. First thing we're going to do is calculate the number of moles of sodium hydroxide. So we know we've got 37.5 centimeters cubed of 0.1 mole sodium hydroxide. So therefore, the number of moles is 37.5 divided by 1,000 to turn into decimeters cubed times by 0.1, the concentration, which tells us the number of moles of sodium hydroxide. We can then use that to work out how many moles of arsenic acid. We know from the equation we've got 3 moles of sodium hydroxide to every 1 mole of arsenic acid. So we need a third less arsenic acid. So we divide the number of moles by 3, giving us 0.00125 moles of arsenic acid. We can then calculate the volume of arsenic acid. We know we've got 25 centimeters cubed, so we divide by 1,000, turn that to decimeters cubed. We can then calculate the concentration using the equation number of moles divided by volume. So that's 0.0125 divided by 0.025 gives us a concentration of 0.5 moles per decimeter cubed. Question 8 says calculate the concentration of hydrochloric acid in moles per decimeter cubed. So this is another titration calculation. We've got information about the titration, we're told the volume of sulfuric acid, and we've got the volume and concentration of barium hydroxide. We're going to use the two equations throughout the calculation. The first one we're going to calculate is how many moles of barium hydroxide we've got. So we know we've got 23.5 centimeters cubed. We need to convert that to decimeters cubed, and it's a 1 mole concentration. So 23.5 divided by 1,000 times by 1 mole gives us our number of moles of barium hydroxide. We can then use that to calculate how many moles of sulfuric acid. From the equation, we can see we've got 2 moles of sulfuric acid for every 1 mole of barium hydroxide. So we multiply the number of moles of barium hydroxide by 2 to give us 0.0047 moles of hydrochloric acid. We can then work out the volume of hydrochloric acid. We're told we've got 25 centimeters cubed. So divided by 1,000, that gives us 0.025 decimeters cubed. We can use those two numbers, the volume, number of moles, and the volume, to work out the concentration, giving us a concentration of 0.188 moles per decimeters cubed of hydrochloric acid. Question 9 says calculate the concentration of sulfuric acid. It's a titration calculation, so we're given information on the titration, including the volume of sulfuric acid and the volume and concentration of sodium hydroxide. We've got two equations we're going to use throughout, and the first thing we're going to do is calculate how many moles of sodium hydroxide. So we're told volume and concentration, so we're going to use the equation number of moles equals concentration times volume. Our volume, though, needs to be in decimeters cubed, so we need to divide that by 1,000. That tells us the number of moles of sodium hydroxide. We can use that to work out how many moles of sulfuric acid we've got. Looking at the equation, we've got 2 moles of sodium hydroxide for 1 mole of sulfuric acid. So we need half the amount of sulfuric acid. So we've got 0.0125 moles of sulfuric acid. We can then work out the volume of sulfuric acid in decimeters cubed just by dividing 30 by 1,000. That gives us 0.3. And then we can use the equation concentration equals number of moles divided by volume to work out the concentration of sulfuric acid. Number of moles is 0.0125 divided by 0.03 decimeter cubed. That gives us a concentration of sulfuric acid of 0.417 moles per decimeter cubed. Question 10 says calculate the concentration of sodium hydroxide in moles per decimeter cubed. It's a titration question, so we've got the volume of sodium hydroxide and we've got the volume and concentration of oxalic acid. We're going to use the two equations throughout, and the first thing we're going to do is calculate how many moles of oxalic acid we've got. So we know we've got 15 centimeters cubed. We need that in decimeters cubed, so we need to divide by 1,000, and we know it's a concentration of 0.48. We can use number of moles equals volume times concentration to work out the number of moles. So that gives us 0.0072 moles of oxalic acid. We can use that to calculate how many moles of sodium hydroxide from the equation. We know we've got 2 lots of sodium hydroxide from every 1 mole of oxalic acid. So we multiply the number of moles of oxalic acid by 2 to get the number of moles of sodium hydroxide, so 0.0144 moles. We can then calculate the volume of sodium hydroxide in decimeters cubed by dividing 25 by 1,000. We can then use the volume and the number of moles to work out the concentration. So it's 0.0144 divided by 0.025 to give us a concentration of 0.576 moles per decimeter cubed. Hope you found these questions useful. Please subscribe and I'll see you next time.